Moving on to lateral area and surface areas of right cylinders. So, before I go into it, see if you can maybe reason this one out yourself. If you knew the radius of this cylinder and the height of the cylinder, how could you figure out the lateral area and the surface area? I will remind you the difference between them. Lateral area means we're not including any bases. Cylinders have two bases. So not including that, just the white part going around. Can we figure out the area of that? And if we can, then we can certainly get the area, the total surface area, because we can just add the area of the two circles. So the question for you is, can you figure out what shape that really is going around there? And if you can figure it out, maybe you can come up with a formula. So here's the deal. The part going around a cylinder. So this part going around the cylinder, when unfolded, is just a rectangle. So let's see if I can do that again. The part going around the cylinder, the lateral surface unfolded, is just a rectangle. So if we can get the area that's rectangle, then we can get the lateral area of the cylinder. And we know how to get areas of rectangles, base times height. So what is this base when we look at the cylinder? Well, it turns out that's the circumference of the circle. The circumference of this circle is the base of that rectangle. And the height of the cylinder is this side of the rectangle, the height of the rectangle. So yes, this can easily be done. We can come up with a formula for sure. Here it is, we'll zoom in. So if you unfold a cylinder, it's really two circles and a rectangle. The base of the rectangle is the circumference of the cylinder, and the height of the rectangle is the height of the cylinder. So that means the lateral area, which is the rectangle, is its base times its height. The base is circumference, and the height is the height of the cylinder. The formula for circumference is 2 pi r. So the lateral area is 2 pi rh. And as we said, if we know that, we can get the surface area just by adding 2 times the area of each circle. So those are the formulas. You're going to find these much easier than prisms. I'm going to hold up 3 pictures for you to look at, 3 problems for you to look at. Let me frame this. There we go. So depending on how big the screen is you're watching this on, maybe I should read the instructions. It's asking for the lateral area and surface area of each right cylinder. So notice it did not say to round. So you can hit the pause button and try that. I'm also going to zoom in on each one individually in just a moment. So the first one, diameter 12 inches, height 15 inches. So you can pause there if you need to. Second one, the circumference of the base is 9 centimeters, height is 10 centimeters. Last one, area of the base, 49 pi feet squared, and the height is 11 feet. All right, can you get the lateral and surface area of each one? Here's number 1. Fairly straightforward. If the diameter is 12, of course the radius is 6. So 2 pi rh would just be 2 pi 6 and the height of 12. Why did I write 15? That's a mistake. Oh no, it was 15. Diameter was 12. So 2 pi 6 15. So 6 times 15 times 2 is 180. 180 pi inches squared. Surface area starts off the same, 2 pi rh, but we're adding 2 pi r squared because we have to add the two circles. And again, if the radius was 6, then we're adding 2 pi 6 squared. 36 times 2, we're adding 72 pi. So the exact answer, 252 pi inches squared. All right, the second one, just to remind you, was this. Circumference of the base is 9 and the height of the cylinder is 10. Now remember, height doesn't necessarily mean up, down. It means the distance between the bases. So this is the height of 10. And the circumference of the base is 9. So in order to use our formula, we have to know what the radius is. Well, we can figure out radius if we know the circumference. Circumference is 9. Then let's take our circumference formula, which is 2 pi r, and replace circumference with 9. So 9 is 2 pi r. 9 is the circumference. So I just divided both sides by 2 pi, and there's my radius. If you want to, you could write this as 4.5 over pi, not 4.5 times pi. That pi needs to stay in the denominator. So 2 pi rh. Just fill in my radius, fill in my height. The 2 pi and the 2 pi cancel, so 90 centimeters squared. 90 centimeters squared. Surface area, 2 pi rh plus 2 pi r squared. So again, the 2 pi from the formula and the 2 pi from the radius cancel. So that's nice. I'm left with 9 times 10. There's the 90 for the lateral. But we have to add 2 pi radius squared. So to square a fraction, you square the numerator. 9 squared is 81. Square the denominator. 2 pi times 2 pi is 4 pi squared. I did a little bit of algebra, some simplifying here. I guess 2/4 simplifies to 1/2. And also 1 pi in the numerator and pi times pi in the denominator. If we really write that out, there's a pi in the numerator and a pi times pi in the denominator. 2 pi's in the, not 2 pi's, but pi times pi. 1 pi factor in the numerator and denominator would cancel, leaving us with just 1 pi in the denominator. So that's why my answer is, after this pi cancels with one of the 2 pi factors down here, my answer is 90 plus 81 over 2 pi centimeters squared. Okay, the last one was this one. No, it wasn't. It was this one. If the area of the base is 49 pi feet squared and the height is 11. Well, not too different from before. If we're given the area of a circle, then we can figure out the radius for starters. We know the formula for area of a circle is pi r squared. So I'm going to replace the area of a circle with the formula. Pi r squared is 49 pi. Divide both sides by pi, take the square root of both sides. The radius must be 7. And the height was 11. So 2 pi rh. Answer 154 pi feet squared. Sorry, I didn't have that in frame there. 2 pi rh. Over here is the surface area. 2 pi rh plus 2 pi r squared. So the lateral portion comes out to be 154 pi feet squared. When I add the two circles, I get 98 pi additional feet squared. Add them together. Final answer, 252 pi feet squared. All right, good. You know what? I do have one more that's worth trying with cylinders. What if I tell you the surface area of a cylinder is 528 pi millimeters squared? So I'm telling you the surface area, and I tell you its height. Can you figure out the diameter of that cylinder? Why don't you pause it and play around with that for a moment? All right. Let me start up here. So what I did was I wrote out the formula that we came up with for surface area of a cylinder, 2 pi r(h) plus 2 pi r squared, and I filled in everything I knew. I substituted that I know the surface area is 528 pi. I know the height is 13. All right. Well, that leaves me with only one variable. The only thing unknown in this equation is the radius. Remember, pi is a number. This only has one variable in it, so we should be able to solve this. For starters, 13 times 2, I just made 26. And I noticed that all of these terms have a factor of pi. So if I divide both sides by pi, then the pi terms cancel, right? These cancel, and that pi cancel with that pi. So now I've got 528 equals 26r plus 2r squared. I also noticed there's a common factor here of 2. I could divide both sides by 2 if I want to. Just get some smaller numbers to work with. So that got me this equation. 264 equals 13r plus r squared. And that should be telling you we're going to be solving a quadratic equation here, either by factoring if you know how, if it's factorable, which it is, or if you don't know how to factor, you can always use the quadratic formula. So we've done plenty of work with those. Let me just slide this, get a good shot of my work here in case you tried it and didn't come up with the right answer. The right answer, by the way, is that the diameter is 22 meters. So there's my quadratic formula work. With my A value of 1, my B is 13, and C is negative 264. Now, even if you didn't divide both sides by 2, you should still get the same answer in the end. So you can check your work against mine. Radius can't be negative, so the radius had to be 11, but the question was diameter, so that would be 22 millimeters. All right, hope you did well with that.